Hello student and welcome to our today's class. Today I want us to discuss about a new area which is related to probability known as the set theory. That set theory is actually an area whereby we are going to see a combination of things that happen in real life situations. But first thing you need to understand what is a set. A set, I can simply say that it can be anything. You can have a set of students, a set of parents, a set of politicians, a set of cows. It can be anything that you are focusing on. And therefore, we will start by looking at the different types of sets using the notes that I gave you and which I'm going to share here as we discuss. As I've said, a set is anything that you are interested on. If, for example, I'm interested with the politicians, then my set will be a set of politicians. If, for example, I'm interested with the students, then my set will be a set of students. It can be a set of cars, it can be a set of maybe footballers and all that. Anything that your focus is on. Here now, for a set to be complete, it is going to have some requirements. A set must be well defined. Well defined in such a manner that it does not bring in confusions or ambiguities. If, for example, I'm referring to a set of students, then those people who I'm referring as students, somebody else also will define them as students. So we should not have a confusion whereby who I'm referring as the students are not actually what you refer as students, or you have your own definition to students. And then the objective, which are also the elements of the members of the set, must be distinct. Actually, they must be clearly be known, and actually they are actually known and well in advance. There's no way you can be able to maybe confuse them. And then you are going to have actually in set, the elements will always be in brackets. The elements will always be in brackets. So let us briefly talk about the types of sets that we have. We have got the universal set. The universal set, whose explanation is given here. The universal set is actually a set of all the things that you are discussing, actually where your focus is. Like, for example, if I'm talking about a set of students, then all the students, maybe it is a set of students in KIPS College. It simply means that all those students who are in KIPS College are actually going to be in this universal set. All of them, they are going to be in the universal set here. If, for example, I'm talking about the members of parliament in Kenya, that is the National Assembly, then all the National Assembly members of that particular house, then they are my universal set. When they are all of them combined without omitting anyone, it is the universal set. Then we have what we call singleton set. A singleton set is actually a set that contains only one element. We have got only one element that will qualify to be in that set. Like, for example, if I say a set of KIPS principle in the year 2020, we only know that in the year 2020, we had only one KIPS principal, who is Sir Evans Omoyo. So you will find that it is only one person who will qualify to be in that particular set. If we have a set whereby only one item is going to be in that set is known as a singleton set. We can have maybe a set of maybe a number that a set of a number whose square root is 2. We already know that it is only 4 whose square root is 2. Then, because it is only 4, then that is a singleton set. Only one element will qualify to be in that set. Then we have got another set we call the finite set. The finite set, it is a set that contains definite number of elements which are actually countable and they are known. The total number is known. Like for example, you are given here the set of all colors in the rainbow, which we know there are 7. So we all know there are 7. You can have maybe a set of the members of the cabinet. We know who qualifies to be the members of cabinet, and we can be able to count them, and we know the number. We can also talk about maybe a set of the members of the Senate, or the Senate as a house. We can count them and we know their number, and their number is an exact number. That kind of a set is known as a finite set. We cannot have more than that. We cannot not have less than that at any particular moment. We can have, like, for example, a set of a football team in a football ground who are playing. We know they need to be only 11. That is a finite set. They cannot be more than 11. Then we have infinite set. Infinite set, it is a set that can have elements whose number is not known. The number can be so big, we don't know actually the end point. That is an infinite set. Like for example, if you are told the set of all numbers or all digits, the numbers can be so many. We can have millions, trillions, and all that. We don't know where the end will be. A set of all the stars in the sky, we don't know actually the number. So that is an infinite set. Then we have got what we call equivalent sets. Equivalent sets. Equivalent sets are those sets, like for example, if we have a set A, which has got 1, 2, 3, it has got 3 elements. Set B has got P, Q, R, which are 3 elements. We can simply say that those sets are actually equivalent. They are actually equivalent because they are having the same number of elements in them. Then we have got equal sets. Equal sets are those sets that contain the same elements. Equal sets, they are those sets that contains the same elements, but not necessarily in the same order. Like here we have set A has got P, Q, R, S, and set B has a P, S, R, Q. You can be able to note that what we have in the bracket of A is also in the bracket of B, even though the order or the sequence is not the same. So set A and set B are equal. Then we have got the empty set. An empty set, it is also known as the null set. It is a set that cannot contain anything. There is anything that can qualify to be in that set. Like for example, you can have something like that, a set of married bachelors. There's no way somebody can be married and at the same time is a bachelor. So there's no one who can qualify to be called a married bachelor. Therefore, that one is an R set. So you can think about others. You can think about other things that they cannot actually qualify to be that. Like, for example, a meeting of dead people. There's no way dead people can meet. So that is a null set. Such kind of things where none is going to qualify to be in that bracket. Then we have got a subset. A subset arises where there is a bigger set and there is a smaller set. The bigger set will contain all the elements that are in the smaller set. All the elements in the smaller set are in the bigger set. Like for example, if you have the alphabet A up to Z, that is now our bigger set. And then we have got a smaller set which has got A up to H as the alphabet. So this smaller set is a subset of the bigger set because A to H is also contained in the bigger set that has got A to Z. So now you find that the smaller set is a subset of the bigger set. Like for example, if we come here in KIPS and we say that we have got a set of all students in KIPS Technical College, that becomes the major set or the bigger set. And then we go ahead and we say a set of business studies or business department students. So you'll find that the business study students, they are going also to be contained in the set of all KIPS students, and therefore the business study students is a subset of the KIPS Technical College students. That is what I mean by that explanation. Then we are going to have actually, those are the types of sets that we are going to discuss. So you need to understand what they mean and what they comprise, because more often than not, you can be tested that in an examination, and you'll find that those are free marks that you need to grasp as you tackle your exam. Thank you very much.